Hi, my name is Lucian, and I want to talk about how we can gauge the success of an Agile team through metrics that we can mine automatically. How should non-technical managers gauge the Agile team's success? I want to go through a list of different metrics that we can use, and we want to find out how we can use them, why these metrics are useful, how do we use those metrics to guide the team to a better result, what actions can teams take to improve the team's results, how should we prioritize these actions, and how can we data mine this information so that we don't bog down the team with finding this information. Bugs are a pretty easy metric. We want the bugs to always be zero, and we want to eliminate any existing bugs. Bugs dramatically reduce the maintainability, and the best way to guide the team, and I mean this in a sense of retrospecting, is to ask the entire team whether bugs should be addressed first and why, and retrospect on that. Actions regarding this metric is to put the code under unit test, refactor, and fix the code. Bug counts should be zero, should be a top priority, and we can data mine this, but it requires some manual data entry. Frequency of deployment to production is another primary metric. Our team currently deploys to production twice a day, and we have an environment where continuous deployment is possible. The usefulness of this metric is that whether or not you can deploy is a strong indicator of whether or not your build process has been worked out and whether or not you have problems somewhere else in your stack. The way you can guide your team to this conclusion through retrospection is to ask them about how they should refine the process and how they build confidence in the application. Actions that the teams can take is to work together to do deployments in what we would call a mob, or we set up a continuous integration server and have the build automatically deployed to a production environment. The priority of this is as long as your bug count is zero, you should be able to do this. We can data mine this. We can log deployments or mine continuous integration servers. Code coverage is another good metric. We use test-driven development, full stack tests, and everything is automated. This means that we can verify that the code is working the way we expect with a simple command. Whether it's new code or legacy code, code coverage should be high. The usefulness of this metric is the idea that low code coverage means problems go unresolved longer, where high code coverage means that you can be more confident in your code. A way to guide your team through retrospectives is to explore frustrations with code changes changed by other developers. Actions that you can take to get more code coverage is to write tests until you're no longer uneasy about changing the code. This is the idea of testing until you're bored. This should be top priority during coding. You should be using test-driven development and creating full stack tests once features are complete. You can data mine this. Most IDEs and continuous integration servers allow you to do so. Eliminating dead code is also a primary metric. Many tools can detect dead code, and once you remove dead code, it is typical to find more dead code. Dead code is denoted by private methods that are not accessed or private variables that are not accessed. This typically makes it just harder to maintain the code. So the usefulness of this metric is less dead code means greater maintainability. A way to guide your team to this conclusion is to explore their thoughts on maintaining the code. This should be done in retrospective and can bring them to this conclusion. As for actions, when the code is under test, you can refactor. This means that you can identify dead code and remove it. Once you have your project under test, this should become your top priority. You can data mine this information, and it would be useful as a performance measure as well. Heat maps are another great metric. The number of times a developer has to work on a single file repeatedly is a strong indication of whether or not that chunk of code fulfills a single responsibility or fulfills too many responsibilities. This is typically seen in a tug of war where two developers are working on the same file repeatedly because the same bugs are introduced over and over again. Problem areas require constant maintenance. How often are files revisited is the question that should be asked during a retrospective, and exploring ways to resolve those issues. Actions that you can take are test, refactor, and decouple. This means that you'll go in and use interfaces and decouple code that is tightly coupled and replace certain functionalities that are problematic with perhaps two different implementations because they really are responsible for two different things. The priority for this is to address this problem immediately, and you should use your source control system to data mine this information and evaluate where those problem areas are. Lowering the amount of overtime is another great metric. People working overtime typically write bad code. People who write bad code during overtime build a technical debt, and then the code becomes less maintainable. Therefore, it slows down the writing of future code, and that can impact the project quite a bit, especially if there's a lot of overtime. Maintainable code will allow for better, faster development, and that is why this metric is useful. What is our quality of work during overtime? We should ask this during retrospectives to find out where we really use overtime and why, and what value it has. An action for this is to work with less estimations and create more deliveries. I say less estimations because estimations are really guesses. If we've done something repeatedly, that means we should have automated it already. If we are doing something new, then there's no use in estimating it. So ultimately, we want to work with less estimations and have more deliveries. More deliveries means that we can steer the project in such a way that once a deadline comes, we can cut the features that were no longer useful and allow us to have the most useful features available in the application with the allotted amount of time. The priority for this should be continuous and top priority. You can data mine this by logging the developer's overtime and comparing it to other metrics during that overtime and even resulting after that overtime. Time spent working on code is a metric for developers. Developers enjoy working on code, and meetings have always distracted from the primary goal. Collaborators should be working with the developers while they write code. Therefore, there should be little to no use for meetings, aside for maybe a project kickoff or some general meetings that the company has. Happier developers will write better code, and the usefulness of this is we also get more coding time with happier developers, and we have less time wasted in meetings. A way to guide ourselves to this conclusion is to retrospect on what do we accomplish in meetings that we don't in collaboration. What is distracting us from allowing us to code better? Actions are business experts and testers should be present during development. Time in meetings should be a minimum. This will allow for all the right people to be in the same room at the same time and develop the best, most useful software first. This is another top priority in general. And the way to data mine this is to log time not developing and compare it to other metrics. Continuous integration is typically an automated build server that will allow tests to run and allow you to get notifications about various metrics. This is nice because you can automate the collection of your metrics and get those metrics every day. You can retrospect and find this to be useful by asking what will give us reliable and constant feedback. How can we find issues quickly? Actions we can take is to unit test, complete full stack tests, code coverage, and it should all be automated by a continuous integration server. This is another top priority. And yes, continuous integration servers can be data mined because they keep a lot of great information. Cohesion is a great metric at the code level. Everything that should be together, belongs together, resides together. This reduces the amount of time that a developer must look for relevant information. It increases the maintainability of the project because the developer doesn't have to go looking for certain chunks of logic that need to be changed and so on. A great way to guide the team to this conclusion is to reflect on how we locate code and how long it takes. Actions we can take is to refactor projects, move classes and methods into properly related locations, and that way they'd be easy to find. Once under test, you can refactor, and it becomes a priority. You can data mine this information by searching the code repositories for related terms and patterns and ensuring them that they are in similar locations. Coupling is the separation of responsibilities. Now, loosely coupled code is maintainable, and that means that interdependencies are very low. So the usefulness of this is that you won't have to rewrite a certain chunk of code to make it testable if it's loosely coupled, because then you can easily use fakes and mocks. This is a primary example of how to make code maintainable quickly. A great way to reflect on this is to ask the team whether the code is easy to test, is it hard to maintain. Great actions that we can take is to extract interfaces and refactor to use interfaces and make it easy to mock and fake in tests. Priority, once under test you can refactor, and it is a great way to make sure that your dependencies are not tightly coupled. Yes, we can check the interdependencies in the code to ensure use of interfaces over classes and data mine that information. Less comments and more expressive names is a great metric. Comments are typically misrepresented as great ways of telling the developer looking at the code what the code does. But in fact, comments are not code, and they can contradict what the code is actually doing. Comments are just a distraction, especially after the first few iterations in the code, because the code becomes less and less maintainable over time, or the code becomes less and less like the comments over time, especially if the team is not paying attention to updating the comments. The usefulness of this is that code named with dictionary words is easier to understand, and that means it's more maintainable. If the code is named properly, everything should read like a sentence, and you should be able to determine what the uses of the code are through the names of the segments of code. It's much easier to follow than comments. A great way to retrospect toward this are asking the team whether comments are easy to ignore, is the code easy to read, and basically find out why we're spending so much time writing comments when they may not be used as much or maintained as well as the actual code. Actions we can use is to use dictionary words for naming, refactoring, getting the code under test, of course, before refactoring. The priorities, once you're under test, you can refactor, and you can data mine this by evaluating occurrences of dictionary words in code, not in comments. Cyclomatic complexity is another great metric. Numerous test scenarios per method is less maintainable, and that's what results from cyclomatic complexity. It's basically the number of branches logic needs to make before the execution of a particular set of code. Cyclomatic complexity is another great metric. It's the number of branches that logic needs to make before executing a particular line of code. Cyclomatic complexity provides the amount of test scenarios per method that would be required to get total code coverage. And numerous test scenarios for a method is less maintainable because once you change that method, then you have to evaluate all the tests that relate to that method. Less special cases means better code, more maintainable code. A great way to retrospect on this is to find out if the team thinks that there are large logic branches hindering them and what to do about it. Actions: refactor under test and reduce the complexity. This will allow you to separate the concerns of methods and break down the cyclomatic complexity and make the tests relate to individual methods rather than a single method. This should be a top priority once you can refactor. This should also be data mined through tools that can calculate cyclomatic complexity, which is very common. Identifying problems. So here we have listed a number of metrics, and we now want to find out how we can use these metrics to identify problems in the code and later reward our developers for better practices used. So this is a list of interesting information that I've come up with that would allow us to immediately detect issues in code and see that we're fixing them. Of course, bug count greater than 0 is a problem. So we don't want our bug count to be greater than 0, and we avoid it. Code changes while not under test is a problem. This can be calculated via a continuous integration server or through the source control system. Frequent revisiting of a file we discussed, and that is also a problem. Similar code not generated is a problem, and that can be calculated through your source control repositories. Overtime is greater than 0 is a problem. Deployments per week is less than 1. That's a problem. If you cannot deploy within a week or are not interested in deploying within a week, then you're missing out on great information that you can get from your users. Any file line count greater than 1,000. 1,000 is a pretty generous number. I really think that your line counts should stay below 300. But 1,000 is, I've seen broken many times, and it's great to separate concerns, and this is just a warning that there is a problem. Nightly continuous integration build broken, that's a problem. And cyclomatic complexity greater than 10. I throw out 10 as an arbitrary number. I try and keep it below 3, but sometimes you can't avoid that, and this has been a topic of much debate. I would say greater than 10 is the time that you begin to evaluate cyclomatic complexity as being a problem. With that, you can quickly go in and address these things. You can say, what are my bugs? What code was changed that wasn't under test? That's probably broken now. Frequent revisiting of a file, that's probably a problem area. Similar code that's not generated. We're wasting time developing the same thing repeatedly. Deployments per week less than 1. That means that we're not getting enough information. Overtime greater than 0. We're unhappy and we're writing less maintainable code. Any file line count greater than 1,000, find it and refactor once you're under test. Nightly continuous integration build broken. That shouldn't even happen, but if it does, that should be a top priority. Cyclomatic complexity greater than 10, your code is too complex and you should break it down and refactor until the cyclomatic complexity has been reduced dramatically. On to rewarding your developers for performance. These are a list of metrics that I would say are a great way of finding out if your developers really have your best interests in mind. Deployments per week greater than 5. This is a great performance metric, and we do this in my office. We have 2 releases a day, at least 5 a week, and it's a great way of finding out if your team is performing well. Line counts per file this week minus the line counts per file last week is less than 0, meaning that you have a decrease in number of lines per file means that you're having great refactoring being done. This is another great performance metric. Lines of dead code deleted, also a great performance metric. And development time is 100%. This is an ideal. Working towards 100% development time and reducing the amount of wasted time is a great performance metric. This means collaborating with business representatives and testers. Similar names in locations. This is a cohesion metric, and this is if you have high cohesion and it's evident from your automation, then that is a great metric. Using interfaces versus classes, that's a coherence metric, and it's great. Dictionary words in definitions. This means method definitions and variable definitions, interface definitions, all have dictionary words in them. That means that we're getting closer to more maintainable code through easy to read code. Code coverage is 100%. This is also a great performance metric. This should be rewarded. Cyclomatic complexity is less than 5. This is also a great performance metric. You rarely see cyclomatic complexity less than 5. So in conclusion, you can use these metrics and you'll find problems quickly and address them immediately. You will reward your team judged from metrics that count. You have your team in effect to make the code easier to understand for a non-technical observer, especially with the proper naming and using dictionary terms to name variables. You quickly produce highly maintainable code. You make maintenance a quick and simple process, and creating an awesome environment to work. Thank you very much. My name is Lucian, and this was my talk.